This project focuses on enhancing server responsiveness and scalability by utilizing BullMQ to handle long-running FFmpeg tasks separately from the main Next.js application. The motivation behind the project stems from having a Next.js app on a DigitalOcean server which faced downtime due to CPU-intensive FFmpeg tasks. Offloading these tasks to a BullMQ message queue allows concurrent access by other clients without blockage. Installation begins by using the pnpm command to install necessary dependency packages, streamlining the setup process for the application. Using Windows Subsystem for Linux, WSL 2 is recommended for running Redis, as it offers full Linux capabilities and performance, significantly improving development efficiency on Windows. Detailed steps for setting up Redis on WSL include enabling WSL 2, installing Redis via terminal just as on a native Linux setup, and starting the Redis server, ensuring it's ready for task processing. Once Redis is installed on WSL, it can be accessed from Windows applications via localhost, facilitating interaction between your Node.js apps and the Redis server running in WSL. Pros of using Redis on WSL include utilizing the official Linux build, which offers better compatibility and performance, as well as a development environment that mirrors production setup closely. Cons of using WSL for Redis include the requirement for a specific version of Windows and enabling certain features that may not be readily available to all users. Testing the Redis server's status can be done efficiently using the Redis CLI with a simple ping command. Successful responses indicate an operational server, while errors signify issues connecting. Interpreting the status command output is crucial, as it provides information about whether Redis is running and other service details. If there's a systemd error, an alternative command should be used. An illustrated example of the Redis server status check emphasizes the need to verify Redis's operational status in the terminal for debugging any connection issues. Closing the WSL terminal stops the Redis server unless it's configured to run as a background service, highlighting the importance of maintaining persistent sessions for long-term operation. Key environment variables for Redis setup include configuring host, port, password, and TLS settings, which are essential for connecting your application to the Redis instance. If your Redis instance requires authentication, setting the appropriate password variable is essential. Otherwise, it can be omitted for default installations. To streamline development, the application can run web and worker processes concurrently using a dedicated dev script defined in the package.json, enhancing workflow efficiency. Building the Next.js application for production is initiated with a specific command that compiles the application, preparing it for deployment. Following the build process, starting the application involves launching the Next.js server, which, if properly configured, will also initiate the worker process for handling tasks. This section outlines essential operations required for managing BullMQ tasks, such as starting necessary services, adding tasks to the queue, and tracking job statuses. It is crucial to ensure the Redis server is up and running before proceeding with application tasks, with visual confirmation of the Linux environment showing Redis's operational status. To consume tasks from the queue, workers must be active, requiring simple invocation of the specific logic file set within the worker directory. To enqueue tasks for processing, use the add task function, which creates a new task in the queue. Code snippets reveal how to define job types and establish options using BullMQ features. BullMQ automatically tracks the status of tasks and marks them as complete or failed based on the job's execution outcome, enabling effective job management. For querying the status of specific jobs in the queue, the getJobStatus function is essential, resulting in job state and details being dynamically fetched and returned. Monitoring queue status can be performed via the getQueueInfo function, which aggregates information about job counts across different states, key for operational oversight. The application's architecture centers around three primary components: a Next.js web server for producing tasks, a Node.js worker for consuming those tasks, and BullMQ serving as the message queue. An architectural diagram illustrates the interaction between the web server, worker, and message queue, providing visual clarity to the system structure. Key design considerations must be addressed when implementing background tasks, particularly concerning task tracking and management, ensuring transparency and operational efficiency. For effective polling of task statuses, various methods such as use effect with intervals, React Query, and WebSockets are discussed, with React Query being highlighted for its developer-friendly features. This section provides insight into the project's code structure, particularly focusing on the setup of BullMQ and key functions that facilitate task management and processing. Creating a new queue involves defining connection options with necessary Redis credentials, crucial for task processing and queue management. The add task function is integral for enqueuing new jobs, with its implementation demonstrating how jobs are added to the queue while ensuring unique job identifiers are assigned. The getJobStatus function is vital for retrieving the current state of jobs, including outcomes and errors, enhancing the ability to track job execution and manage results effectively. Returning essential details about job statuses, the getJobStatus function ensures that vital information about job processing is readily accessible for developers. The getQueueInfo function monitors the overall health of the task queue, encapsulating counts of tasks waiting, active, delayed, failed, and completed, vital for operational integrity. This section visually illustrates the application's functionality, showcasing how tasks are added and monitored within the system through example images. The process of adding a task to the queue is depicted, emphasizing the impact of job IDs for tracking and managing tasks effectively within the system. Tracking job status via a generated job ID is illustrated, demonstrating the interaction between the application interface and back-end task processing. Points of interest highlight challenges such as code duplication in separate projects, Redis connectivity issues, and how updates in job status require specific configurations in Next.js to ensure proper rendering. Illustrative examples show situations where users must debug issues with task processing, including potential worker spawns beyond expected capacity. This section includes valuable references for further exploration of BullMQ and related project improvements, guiding users to external resources and documentation.